Hi everyone, welcome to RMS classes. If you are new to this channel, subscribe my channel. So today topic is indeterminate forms. Let's see the theory of indeterminate form, then we will go to the solving numerical problems. Okay, if an expression f of x at x is equal to a is in the form of 0 by 0, infinity by infinity, 0 into infinity, or etc., which do not represent any values, are called as indeterminate forms. Next comes to L'Hospital rule. So what is L'Hospital rule? If the f of x into g of x is a two functions such that first one, limit f of x where x tends to a, that is equal to 0, and limit g of x where x tends to a, that is equal to 0. Second one, f dash of x and g dash of x exist and g dash of a is not equal to 0, then limit f of x divided by g of a where x tends to a, that is equal to limit of f dash of x divided by g dash of x where x tends to a. So L'Hospital rule can be applied only if the function is in the form of 0 by 0 or infinity by infinity. Then we can apply L'Hospital rule. So in you more clear in solving problem. Okay, so first problem is evaluate limit tan x into log x where x tends to 0. So here consider let k is equal to limit tan x log x where x tends to 0. So put wherever x is there 0. When we put tan 0 is 0 into log 0 is infinity, so it is in the form of indeterminate forms, so we cannot simplify this. So we cannot put limit for this because it forms infinity forms, that means indeterminate forms. So let us simplify the given equation. So here tan x can be written as cot x, that is tan can be written as 1 by cot x, that means log x divided by cot x. So here put wherever x is there, so log 0 is infinity and cot 0 is infinity, so it is in the form of infinity by infinity. So here we can easily apply L'Hospital rule, because L'Hospital rule apply only if the expression is or given equation is in the form of 0 by 0 form or infinity by infinity form. So here the given expression is in the form of 0 into infinity form, therefore I will reduce in the form of infinity by infinity by doing some simplification, that is using trigonometry relations. Okay, that's all. Then apply L'Hospital rule to this. So L'Hospital rule says that, so here look at this, here limit of limit of f of x divided by g of x where x tends to a, that is equal to limit of f dash of x g dash of x. So differentiate numerator and denominator separately, then also it does not affect the previous, so that is a given expression. Okay, so apply L'Hospital rule, that means differentiate numerator as well as denominator independently. Okay, differentiation of log x is 1 by x and cot x is minus cos x square x. Let us simplify it. So 1 by x I can put down in the numerator, the denominator it becomes 1 divided by x cos x square x. So cos x square x goes in the numerator, it becomes sin square x. So before so here minus as it is, so limit of x tends to 0, so here I can written sin x by x into limit of x tends to 0 sin x, because by the standard result limit of x tends to 0 sin x by x is equal to 1. This is the standard result we have, so this becomes 1. Okay, and this apply limit wherever x is there, put 0, sin 0 is 0, 1 into 0 is, that is 0, k is equal to 0. Okay, next one, limit of x tends to 0, function is a raised to x minus b raised to x divided by x. So let k is equal to limit ax minus bx divided by x where x tends to 0. So put wherever x is there 0, so a raised to 0 is 1, b raised to 0 is 1, 1 minus 1 is 0 and x is 0, so it is in the form of 0 by 0. So here apply L'Hospital rule. A raised to x, differentiation of a raised to x is a raised to x log a, minus the differentiation of b raised to x is b raised to x log b, divided by 1, differentiation of x is 1. Okay, k. So here apply a limit wherever x is there, put the value of x, that is 0, a raised to 0 is 1, a raised to 0 is 1, b raised to 0 is, that is also 1, so it becomes log a minus log b. So here it is in the form of log m minus log n, that can be written as log m by n, that is log a by b is the final answer. Next one, limit of tan x raised to tan 2x where x tends to pi by 4. So let k is equal to limit tan x raised to tan 2x where x tends to pi by 4. So let's check wherever x is there, put pi by 4, it becomes 1 raised to infinity. so it is not in the standard form, that is it is not in the 0 by 0, or it is not in the form of infinity by infinity. Let us simplify it. So here 1 raised to infinity is here, so we have to put in the form of 0 by 0 or infinity by infinity. Therefore I will apply log on both sides. So log k is equal to log limit of x tends to pi by 4 tan x raised to tan 2x. So take log inside, limit of x tends to pi by 4 log tan x raised to tan 2x. So it is in the form of log m raised to n. It can be written as n log m. So limit of x tends to pi by 4 tan 2x log tan x. So now let's check wherever x is there, put pi by 4. So we get infinity into 0. So it is also not in the standard form. Let us simplify it. So tan 2x can be written as 1 by cot 2x. It becomes log tan x divided by cot 2x. Now put the values of x, that is pi by 4. Log tan by 4 is infinity. 1. Log 1 is 0. And that is log pi by 2 is also 0. So here it is reduced to 0 by 0 form. Then apply L'Hospital rule. That is log k is equal to limit x tends to pi by 4. So differentiate numerator, that is log tan x, that is differentiation of log x is 1 by tan x, and differentiation of tan x is sec square x. In the denominator minus cosec square 2x into 2. So here 1 by 2 is the constant. So take outside from the limit, minus 1 by 2 limit x tends to pi by 4. So here sec square can be written as 1 by cos square x into here in the denominator cosec square 2x. Here what is 1 by tan x? That is cot x. So that is cot x. Okay, it becomes cos square x, and here in the denominator cosec square 2x is there. So when it goes to the numerator, it becomes sin square 2x. So here cot x can be written as so here 1 by cosec square is as it is. Cot x can be written as cos x by sin x into sin square 2x. So 1 cos and 1 cos get cancelled. We get minus 1 by 2 as it is. Now limit x tends to pi by 4 sin square 2x, 2 sin x into cos x. By the standard result, 2 sin x into cos x is sin 2x, that is sin square 2x divided by sin 2x. So 1 sin 2x, another sin 2x get cancelled. So here minus the limit of x tends to pi by 4 sin 2x. Here a log k is there, so we have to find the value of k. So no, put the limit, apply limits. So wherever x is there, put pi by 4, that is sin pi by 2 is 1, and here minus is there, so that is minus 1. So here log is there, we have log k is there, so we have willing to find the value of k. So our log is there, so when we come this side, it becomes exponential, that is k is equal to e raised to minus 1 or 1 by is the final answer. Okay, then next one, limit of cos x raised to 1 by x square where x tends to 0. Let k is equal to limit of x tends to 0 cos x raised to 1 by x square. So put the limit wherever x is there 0. So let's check it. So it is also in the form of 1 raised to infinity. Apply log on both sides. We get okay, log k is equal to limit x tends to 0 log cos x raised to 1 by x square. It is in the form of log m raised to n. It can be written as n log n, that is 1 by x square log cos x. Now apply limit. So here 1 by 0 is infinity, log cos is 1 log 1 is 0. So it is in the form of infinity into 0. So here also it is not in the form of standard form. Therefore log cos x, take the denominator x square, that becomes no, apply limit. Let's check. Then it becomes log cos log 0 log 1 is 0 and x square is 0. So it is reduced to in the standard form. Now here apply L'Hospital rule. Okay, limit x tends to 0, derivative of log of cos x is 1 by cos x, and derivative of cos x is minus sin x. In the denominator derivative of x square is 2x, so it is becomes minus tan x divided by 2x. So minus 1 by 2 is the constant, therefore take it outside from the limit x tends to 0 tan x divided by x. By the standard result, limit x tends to 0 tan x by x is, that is equal to 1. Okay, it becomes totally 1, and log k is equal to minus 1 by 2. We have to find the value of k, that is k is equal to e raised to minus 1 by 2, or k is equal to 1 divided by e raised to 1 by 2 is the final answer. Thank you.